Hello and welcome back to yet another episode where I'm attempting to restore a Rogers Majestic Entertainment console from the early 1960s. It all started with a simple disassembly, some hazmat cleanup of zinc chromate paint, then a chassis painting, then putting it back together, then causing myself no end of trouble when I dropped the damn chassis.
Oh dear.
I did make a little progress in getting the turntable to work. And in the last episode, let's just say I tried to recover from the problems I caused in episode 3. I did a rather messy epoxy job to fix the board, and I did manage, as far as I can tell, to find all the breaks and the traces that I caused. Fixing all the breaks was fairly easy. All I did was use some copper tape and a lot of solder and flux. However, it was rather time-consuming. I then started out on my Dunning-Kruger proof by immediately releasing the magic smoke.
No, don't say that.
Peanut butter sandwiches.
I did admit to myself that I might need a little help, so I asked some of the guys at the radio club a few questions, and it was pointed out that running a tube radio without a load is not a good idea. So I managed to hook up the speakers, and then I set out to prove the Dunning-Kruger effect not just one more time, but two. And finally, I asked myself a question.
Why do I even bother?
I've asked myself that question a few times during this project. You know, I had my doubts from the very beginning. This console wasn't a particularly high-end one, and opening up the back only just confirmed that. But then again, I really do like the person I'm restoring this for. I guess I'm just too stubborn at this point to give up. I can tell you this, though, I'm glad I didn't videotape all the time I wasted, attempting desperate measures to get this radio to work. One thing that was on my side was that I took very good notes on what I was testing and what I was doing, and despite me mocking myself for randomly turning switches, it did provide me with some valuable information. The first thing that my notes revealed was that I only blew out that resistor when the mode switch was in the FM position. At least in phono mode, I was able to poke around a lot more and take notes on voltages in a number of key places. In the short term, it didn't help me very much, as I didn't interpret the readings very well. And that led me to try a few Hail Mary solutions. First, I misread the voltage across the old germanium diode, and I swapped it out for a modern one. No luck with that, because I had tested the germanium diode incorrectly. In the end, I just left the new diode in place. I even swapped out the tubes with an extra set I had, hoping that would solve all my problems. But of course, that was just wishful thinking. So after a good long while of fruitless endeavor, I sat down with my testing notes and the schematic to see if I could work out what's going on before I gave up on this project.
One eternity later.
Let's look first at the voltages I got across my valve heaters. In my notes, I'd recorded the voltages of my heaters some 16 times, and this was the average result. For valve 1, I expected 20, got 0. Valve 2, expected 20, got 0. Valve 3, expected 20, and got 0. And valve 4, I expected 50, and you guessed it, I got 0. And finally for valve 5, no surprise here, I expected 50 and got 0. This was rather frustrating because I had thoroughly tested the filament circuit with my signal generator, and I found no fault. It does explain why I swapped out the tubes in desperation. This review of the circuit diagram gave me a much better understanding of how the filament circuit works. In fact, there are two separate filament circuits. One in DC that goes through valves 1, 2, 4, and 5 at 20, 20, 50, and 50 volts, which gives a series drop of about 140 volts, which is fine for the 130 volts that's found on the B+. The second filament circuit is AC only, and it passes through V1, which is only a 20 volt filament. So you would think 120 volts AC would kill it rather quickly, but looking back along, there is one large high wattage resistor and two pilot lamps, each of which have an NTC resistor in parallel with them. Fortunately, the parts list gave me what type of bulb was required, and I found out it was an 18-volt bulb, which is rather odd. It all works out in the end, as the lamps and the resistor add up to about 56 volts, and the 10-watt dropping resistor is more than sufficient to handle the voltage. Of course, it's good to know how the circuit works, but it didn't help me much at this stage. Looking closer at the schematic, I saw that there were 4 listed test points. The first one here, but that doesn't do me much, as I think this point is an injection point for an RF signal. And again, test point 2 is just another injection point, and this time I think that would be for a modulated FM signal, so nothing here. And point 3 is just a tie to ground, so that should be 0 volts. Finally, there is test point 4, which is just another RF signal injection point. As I was in audio mode, only one of the test points had any voltages, negative 130 volts at test point 3. Probably explains why I swapped out that diode, as 130 negative is not what you'd expect here. I did take a number of voltage readings in the audio section. Across the diode, the expected voltage was 140, and that's what I was getting. So that's good. Resistor 54 was next, and I was expecting about 130, but only got 4. Here at the B plus point, I was expecting 130, but got negative 42. Now at R56, I was expecting about 18 volts AC, but was getting 50 volts AC. And the same thing for R55. So all in all, quite confusing. Even the guys at the radio club could give me no explanation. And then it dawned on me, I wasn't really getting a negative 130 volts here at test point 3. I was getting positive 130 volts, as I was putting the negative end of my meter at test point 3. I just swapped it around and presto, 130 volts positive. Not a voltage you would expect to see on a ground line. Then I remembered what one of the guys said at the club, that if I didn't hook up the speakers, this point here, X2, would mean that I don't have a ground path for any of the capacitors here.
Eureka!
So after many hours of snooping about in here trying to figure out what was wrong, I think I finally figured it out. My pokey stick here. Right up my pokey stick. Grab a pokey stick when you want one. So what I'm getting is no flow through my system. So I just keep getting the same weird negative voltages, but I do get voltages to these caps here. And what is it? Was that this is a negative rail, but this negative rail to all these caps isn't connected anywhere to the other negatives over here. Let me zoom in, you can see here. Zoom, 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 zoom. Let's see. Yeah, so this... Yeah, so this negative rail here, where the mains power comes in, isn't connected to anything else, and there's no connection between this one and this main plane here. And what it was with the other caps, don't have one handy, but the other caps had an outer can where the can connected here, 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 and here, and the can was negative. So that was the problem. If we look back at the circuit diagram, one can see what exactly went wrong. I took the ground for these 2 caps and these 2 caps out of the circuit. So now my circuit looks something like this. Unfortunately, the problem isn't just that simple. The hot end of my AC was connected to this trace. But in order for the circuit to actually work, it would have to be connected to this trace as well, as that's the main ground plane for the rest of the circuit. If you look at the bottom of the capacitor can, you can see 3 lugs that all connect to ground. The can sat in the circuit board like this, with its 2 positive connections here and here, and its 3 ground connections here, here, and here, and it's this one that bridges that gap between the 2 ground planes and connects up the line AC. So without the main ground plane connected, who knows which way the voltage is going to flow. I'm just lucky it didn't cause more damage when I turned it on. So I'm going to chalk this up as a good learning experience. Now let's see if I actually solved the problem. So the solution is to put in a bodge wire from here, where there just happens to be a hole, into this negative hole here, and that should connect the 2 up with the positive, and then I should be good to go. We'll hook that up and see what happens. So I've double and triple checked, and I've marked my positive hole with a little dot. So the positive end goes in here, and the negative goes there, and this little bodge wire will go across like that. Okay, so in the end I decided to put a little L corner on that. It just fits in better. Don't get as crowded as I did before. And I'll solder that in place. There we go. According to theory now, I should have continuity between here, 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 and now here. Yay! Then it goes all the way there, where before I didn't. No continuity there. There. Okay. So, I'm going to clean this mess up yet again and put everything back together again.
20 minutes later.
Here we go for the first power up. Switches are off, dim bulb connected at 50 volts. We should go to 50, and if it's working, we'll flip the switch here. 49, 39, and it's going down because the tubes are warming up. Good. Let's get up to 75 volts. Wrong way. No magic smoke. Getting any glow in there? Don't see any glow yet, but it takes a lot. 62. No magic smoke. Here's 100. Getting 80, 81, 82, 83, which is good. And I think I see a glow in there. Problem is these tubes don't glow very bright. Let's put it to 120 and see what we get. Like that. Hey, we got glow. Very, very faint glow. So that's not too bad. Okay, good. Good, 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 good. I'll let that burn in for a little bit. Turn my lights back on. Don't bounce into everything. Yay! Hoorah! Guess what? We've got hum. We have life.
It is not life as we know or understand it.
The more astute of you out there might have noticed that valve 3 is not in place. Now, it's always good storytelling to leave the audience hanging a little bit, and thus the title of the next episode is